Hi, I'm Arshiya Lal. I'm in ID 3510, and I will be submitting exercises 1 through 14 for the red board kit for the Arduino, which I have right here. This is experiment number 1, blinking an LED. As you can see, energy is traveling through, and the digital write function is what is turning on the LED and turning off the LED using high and low. And the delay function is what is giving the blinking effect to the LED. So this is circuit 2, experiment 2, potentiometer. As you can see, it's the same as the previous one, except the input for the delay is being put in through the sensor for potentiometer. So when I change the dial, it changes the amount of delay, the LED blink. Yeah, and the function making the LED turn on and off is the low-high with the digital write function. So this is circuit number 3, the multicolored light, or RGB LED. What we're basically doing here is we defined the 3 pin colors as we defined different pins, and then we're using digital write to turn on and off the different pins to create the different colors. So we go through RGB, which is turning off and on certain pins, and then we go through yellow, cyan, purple, which is when we have two pins turned on out of the 3 to create that color, and then we do the white, which is all 3 on at the same time with the digital write function. So this is circuit number 4, multiple LEDs. As you can see, we use several loops to first go through every light and turn it off and turn it on, and then delay it so that it goes in a step order. So this is circuit number 5, push button. As you can see, we identified the buttons as the input functions and the LED as the output functions, and using the digital write function and an if-else statement, we make sure that it only lights up when either one of these is pressed and doesn't light up when both are pressed. So this is circuit 6, photoresistor. As you can see, we're taking in the input from the sensor and outputting it on the LED. So we're defining the input from the sensor as light level between 0 and 1023 and mapping that, constraining that to what the LED can output. And we use the analog read function to read what is coming from the sensor, the photoresistor sensor, and the analog write function to write out the light level to the LED. This is circuit 7, temperature sensor. So we're basically using the temperature sensor on this circuit as the input, and we're defining different voltage, degrees Celsius, degrees Fahrenheit, using different math functions, and then using the code serial.print to print what the sensor is relaying, and we're delaying it by 1,000 just so we have a repeat of the voltage, and using the return analog read function to give us the true voltage, and you can see that here. So this is circuit number 8, a single servo. As you can see, we're basically using the servo write function to make the servo move to the next position, which is an angle, and we just define those different angles within the code and use a delay of 20 seconds to allow the servo to actually move to the different degrees. So this is circuit number 9, flex sensor. Here's an example of it. So it goes with the flex of the sensor. And we basically map the input from the sensor. We use the analog read position to read the flex position, and then we map and constrain that to the servo position angle, and use the serial print function to print to actually output the position inputted by the sensor onto the servo. And then we use the delay function to wait between the servo updates. So this is circuit number 10, soft potentiometer. As you can see, we can bend this and to change the color output. So we're basically reading the sensor value from the potentiometer and mapping that to having that as an analog read function, and then creating another function called set RGB to map the input received from the potentiometer into an actual color, mapping it between 0 and constraining it between 0 and 255 to create the different blends of color. And we use the analog write function to display those color values. So this is circuit number 11, the piezo buzzer. As you can see, we created an array of the different notes that we wanted the buzzer to play with different frequencies. And we mapped the output using pin mode, the pin mode function. And then we created a nested if-else function within a for loop. So it steps through the different song arrays, and it might pause or else it'll just play a note. And for the purpose of this demo, I took out the function that would let it pause forever, just so that we could see it repeating the song over and over indefinitely. So this is circuit 12, spinning a motor. As you can see, it's taking in the speed I typed into the serial, which was between 0 and 255, because that is what the analog write function can use as an input. So I'm basically typing in the speed which it's getting from the serial box and using analog write to map the speed to the motor pin output. And I can change the speed, so that would slow it down at 100. So this is circuit 13, relays. We use setting the pin as an output function using the pin mode code, and then we use digital write to turn the relay on using relay pin high, delay it by a second, and then turn the relay off, which is the low function, and that displays on the LEDs. So this is circuit 14, shift register. As you can see, it's going in and turning each of the LEDs on and then turning them off in the reverse order in a loop. So going through them one at a time, and we're using the shift write function, which is just another way of saying the digital write function, to turn the LED to the desired state, be it high or low. And we're using a for loop to go through the index of LEDs and turn them on or off with a delay in between, using a delay time function.